let's see what are those terms and terminology which are very popular in machine learning and data science. So A by B testing. What is this A by B testing? We have seen lot of testing. In hypothesis testing, we know parametric, non-parametric. In parametric, we have seen about T, Z and F test. And in non-parametric, we have seen about chi-square test. A by B testing is one of a similar kind of statistical technique which is used to compare two different versions of a product, web page or a model. Okay, suppose you have two ML models. You have two ML models, ML1 and ML2. Right. So this A by B testing is a statistical technique which is used to compare these two models. Which one performs better? Okay. A by B testing, which is used to compare two different ML models. Or it's a generic testing technique. Even in software engineering, we have this A by B testing technique. That's what we are saying. Compare two versions of a product, a web page, or a strategy. It's a general definition, but it is used in machine learning as well to compare two different ML models. Accuracy. So this is a very frequently used term in the ML and deep learning models. The measure of how often a classification model correctly predicts the outcomes. So we use accuracy mostly for classification problems. Classification, we know whether it's a spam email or not a spam email. Okay, so where we have two things only, binary things, whether it's a spam or not a spam, or you are classifying into, you have multi-class classification as well. So there also we use this metric accuracy. Analytics, a general term of data science. So the process of interpreting and examining the data to extract insights from the data. So that's why data science, data analytics are linked to each other. In one of my videos, if you see in my YouTube channel, I have explained about the difference between data science, data scientist, data analyst. Okay, so we have different roles there. So what is the difference between those roles of data science have been discussed. You may go through that. So analytics is generally about interpreting and examining of the data to extract insights from that. Anomaly detection. So trying to identify unusual patterns or outliers in the data. Unusual patterns and outliers. So we know if I plot the data, if every data is in this region like this, if all the data points are here, if one or two data points are here and here and here, so only these three are called as outliers. So anomaly detection is a technique where we try to identify these kind of outliers. ANOVA, analysis of variance. We have studied this in statistics. We have seen parametric, non-parametric testing techniques. So in parametric, we have seen about T, Z and F. When I talk about T test and Z test, it is between a population and a sample. When I talk about F test, it is between two samples or between two populations, right? We apply ANOVA, analysis of variance technique, if the number of samples is greater than 2. If the number of samples is greater than 2, then you apply ANOVA technique, analysis of variance. In this analysis of variance, we have two different kinds, one-way ANOVA and two-way ANOVA. Okay, what is one way? Analyzing the data only in one direction, only in x-axis or in y-axis. Two-way ANOVA, analyzing the data in both the directions, x and y. Okay, so the example of ANOVA, I'll just quickly recall that what we have seen already in ANOVA, there are 4 workers. So worker 1, worker 2, worker 3 and worker 4. There are 5 machines, M1, M2, M2, M3, M4 and M5. So my goal here is I'm about to test that the hypothesis is that the average or the mean production or the mean productivity of the 4 workers is dependent on the mean productivity of the machines. Okay, so this example we have seen that if there are four workers and five machines, every worker, his mean productivity, is it dependent on the machine's productivity or not? Is the worker's performance is dependent on the machine's performance or not? So for these cases, we use ANOVA. Then we have AUC, area under curve, region of the curve, ROC, AUC, ROC curve. Okay, so this is used in classification model again. So whether how is it performing, whether it is performing, and how your model is performing. Okay, area under the ROC curve is one metric, which is by plotting the graph, we try to do whether the prediction which is done is positive or negative. Again, same thing, accuracy. Yeah, maybe this by mistake has come. Batch gradient descent. We have seen about gradient descent. What is gradient descent? It's an optimization algorithm which helps us in finding the better values for the parameters. What are those parameters? W and B in linear regression. Suppose we have y equal to wx plus b. Finding the best values for w and b, we apply gradient descent. Okay, so like this, we do this for small data, but if you apply that for entire training data set, if you try to optimize this model, you formed it. Okay, if you consider the complete data set, that is called batch gradient descent. Bayesian statistics, so statistical approach that combines prior knowledge. So Bayesian naive Bayes also, we have seen naive Bayes algorithm which combines the prior knowledge and tries to give us the output. Bias. What is a bias? This term B is called a bias. In a regression equation, y equal to wx plus b is called bias. So it's kind of an error variable. Though you are having equation, there is a little chance of error in the data. So that you are considering here an error in the model that causes it to consistently predict values away from the true values. That's why, like confidence interval, no, we are leaving 5%, assuming that 5% can be error. So that is called your bias. Bias variance trade-off. Okay, the balance between the error introduced by bias and variance of the model. Okay, bias variance trade-off, very very important metric in machine learning and deep learning algorithms. To evaluate the models, we try to use this bias variance trade-off. Lot of research people who do research use this metric, bias variance trade-off. So what is it? The balance between the error introduced by this b variable and the variance in the model. Binary classification is a general term of machine learning, categorizing two groups of data into two groups. You have a data set with you, you try to classify into two halves. Bootstrap sampling. In when we studied about estimation techniques, we studied about point estimation, interval estimation. In interval estimation, we use bootstrap sampling method. What is this bootstrap sampling method? What is the use of this? You have a sample with you. You have a sample with you. You are doing estimation here, not point estimation but interval estimation. In interval estimation, you have a sample with you. Again, you try to derive small samples from this sample, S11, S21, S3 dash, S4 dash, and so on. You try to draw small samples from a given sample. These samples are called as bootstrap samples. So when the sample are done with replacement, means, see, it has 10 values only, for example 1 to 10. This sample, yes, has 10 values only with 1 to 10. Okay, I am drawing a sample S1 dash. Maybe that sample I got 1, 3, 7. I am drawing another sample S2 dash. I may get 1, 3, 9 or 8. I get 8. See, with replacement, I am getting same values in both the samples. Okay, so deriving samples with replacement, because sample is very small size, from that drawing more samples, it is high chances that you get repeated values in those samples. So sampling technique by applying with replacement is called bootstrap sampling method, and we have seen how do you use this bootstrap sampling method to give estimation in interval. Categorical data. When we talk about features, we talk about features F1, F2, F3, so on, N. And we talk about the person, serial number 1, 2, 3, 5. So like this, these are features and we have number of rows in each of them. Okay, right? So what are those categorical data? Data which are, I will say, other than numerical data, we have some kind of data maybe color, not color, other example of categorical data can be major course. Okay, one of the features is major course. So generally we have fixed major course like math or CS or electrical or mechanical. So branch of the student can be considered as a categorical data. Okay, variables that represent categories or groups and can take on a limited fixed number of distinct values like this. How many branches do you in your college has? So that can be a categorical data. Okay, so in future this is mech, this is civil, this is CS, right? This is electrical. Like this is production. Like this, you have a feature F3, which is a categorical data, but it is limited. Okay, so in machine learning, generally in data science or in machine learning algorithms in general, when you have categorical data, you have to convert this categorical data to numerical data. How can we convert? By giving a numbering. Math as 1, CS as 2, this as 3, this as 4. That way we can convert a categorical data to a numerical data. Chi-square test. It's a non-parametric testing technique. It is why it is called non-parametric testing, because the information about population or sample is not given to us. Without any such information about population or sample, yes, random values are given and you have to find out the relation between both the variables. Okay, association between two categorical variables. In data science, you have a lot of features. You have to find out whether there is a relation between feature F3 and F7. Like we have seen, the example of chi-square test can be gender and the pet animal. So I have male, female, I have pet animal, dog and cat. So the question here is that does the gender has any that is there any relation between the gender and their pet animal preference? Gender and their pet animal preference. Is there really a relation between gender and the pet animal? Okay, so some data will be given to you. You apply chi-square test and identify the relation between gender and their choice of pet animal. By seeing data, you cannot say that men are always preferring dog and female are all or male are preferring dog, female people or ladies or women are always preferring cat. We cannot say that. You have to do some kind of a testing technique. That testing is your chi-square test. So same thing, bias, variance, trade-off. Yeah, confidence interval. Okay, confidence interval. So this is what we have said. When we do estimation, in estimation we give values as point or as interval. So when you give interval, it is something like this: 65.5 to 73.2. You give an interval like this. Maybe the average weight of students in first year of engineering is this much. For example, I'm making an estimation. I'm giving it in interval range. So what confident, how confident you are that the average weight of students can be this range. So 95% confident. So this is called giving an interval with the confidence is called confidence interval. So it's a range of values used to estimate the true value of a parameter within a certain level of confidence. So I'm 95% confident that it may fall in this range. So this kind doing estimation in intervals is called confidence interval. Confusion matrix. So in classification algorithm, when you do classification problems, you generate a matrix. You generate a matrix, confusion matrix. True positive, true negative, false positive, and false negative. We use these four values. Based on these four values, you try to get a confusion matrix. So this is used in evaluating the performance of a classification algorithm. Okay, so this is used in evaluating the performance of a classification algorithm. Correlation. So degree of association between two variables. How are those two variables related to each other? Covariance. So we know a measure of how much two random variables change together. The example of ice cream and temperature. If you take, so when the temperature is increasing, the ice cream sales are also increasing, right? If that is observed, then we say the covariance between these two is in positive direction, and it is positive covariance, it is increasing. It is covariance is increasing. So it tells a measure of how much two random variables change together. Anyhow, we use this covariance to calculate correlation. Cross entropy loss. So this is also a loss function which is used in classification problem. When you're doing classification, that whether it is a spam or not a spam, we use this metric cross entropy loss as a metric in that. Dimensionality reduction. So this we have studied widely. When you have a large data set with you, we cannot deal with that large data set. We try to reduce the dimension or the size of the data set. Or I cannot visualize a large data set of, I cannot visualize higher dimension data. We can see maximum up to 3 dimension. If there exists some data of 4 dimension data, I cannot visualize it. So we apply dimensionality reduction technique. Then that the very important technique is principal component analysis. We use this technique to reduce the number of features in the dataset while retaining the important information. So we try to reduce the size of the dataset by also a condition apply. We have to retain the important information of that dataset. Eigenvalue, eigenvector. So in matrices, we calculate eigenvalue, eigenvector. So this is very important. These are used in lot of things. Linear algebra and dimensionality reduction. We have seen how eigenvalue, eigenvector are used in principal component analysis. So given a matrix that you try to find out its covariance matrix, you find out eigenvalue, eigenvector, then you find out the highest eigenvalue, its eigenvector, you normalize it, and then you use it in PCA. So in matrices or in linear algebra, we have this concept of eigenvalue, eigenvector. It has lot of benefits in solving large complex problems. F1 score, it's a metric which is used in classification problem. So we try to combine precision and recall. So F1 score is based on these two metrics, precision and recall. And we calculate precision recall using the information of the confusion matrix. Gaussian distribution. Okay, one kind of distribution technique which we have in probability distribution techniques. So it's widely used. Gradient descent, same thing which we already seen. So it's an optimization algorithm which is used to optimize the. It is used in optimizing the parameters of a given ML model. So this is one technique. We have seen an example how we try to optimize a linear regression model using gradient descent technique. Hypothesis testing, very, very popular concept in statistics. We have seen that you have a population's data, you have a samples data. Okay, since you cannot work on this full population's data, you try to derive a small sample. Yes, and you do some operations on the samples data, and you try to find out you find out some metrics, you find out some parameter values. Okay, using the samples data, samples parameter, you will make a comment on the populations data. Using the samples data, you will make a comment on the populations data. So when you make a comment on the population data, it is called hypothesis. Now, whatever comment you made using samples data about the populations data, you are making a comment. That comment is called hypothesis. So, whatever hypothesis you are making about the population, whether it is valid or not, your claim is true or not, that we try to identify using hypothesis testing technique. So, next one, inferential statistics. So in statistics, we have different kinds of statistics. One is inferential. So what is this inferential statistics? We try to make inferences. Okay, we try to make inferences. Like if you remember, maybe in some course of mathematics, you have like this. You have a statement S1 that A tends to B. Then you have another statement S2 that B is tending to C. So you make an inference here that A is tending to C. So you try to derive conclusions based on the inferences. Joint probability. We have studied in probability that there are three kinds of probabilities. One is marginal probability, joint probability, and conditional probability. What is the joint probability? Random events, two events, E1, E2, or two experiments are happening separately. But if they are happening at the same time, okay, if they are happening at the same time, combining the outcomes of both these experiments, okay, is called joint probability. Linear regression, very, very popular method used for prediction. It is a statistical method for modeling the relationship between dependent and an independent variable. Linear regression, it tells us the relation between dependent and the independent variable. Linear regression. Mean absolute error. Okay, the measure of the average absolute differences between the predicted and the actual values. Okay, so you know this is the actual value, this is the predicted value. This is the predicted value. So the absolute difference means the positive difference and its mean. So you have so many values, like this, its mean. So this is your mean absolute error between the measure of the average absolute difference between the predicted and actual values. We use this MAE in regression models or mostly in ML algorithms to find out, mostly in regression when you do prediction, because you're doing prediction. This was the original one, I predicted this. So what is the difference between, what is the error between both? Mean square error is a similar kind of a measure which is also used to find out the difference between the predicted and actual values. So these are very, very popularly used metrics in prediction algorithms. Multivariate analysis, univariate analysis, and multivariate analysis. In statistics, when you do analysis, if you are dealing only with two variables, or you're talking about, see, what case can be multivariate analysis? Example, you are doing analysis of the student's performance based on his math score, based on his programming score. Okay, for placements, maybe you want to assess the placement of the student. So you're analyzing the student's performance in terms of mathematics and programming skills, not only based on mathematics. If you're doing some analysis between the student's performance in mathematics subject and his placement, or programming subject and his placement, univariate analysis, single variable. But if you're dealing with multiple variables altogether, then we say multivariate analysis. Naive Bayes, a very important classification algorithm, which is based on Bayes theorem. Null hypothesis. So in statistics, when we say H naught, null hypothesis means H naught. In statistics, when you make a comment about a population, that particular comment or that particular hypothesis is your null hypothesis. A little added point is that it is assumed to be true until proven as false. H naught is assumed to be true until proven false. That is your null hypothesis. Next one, outlier. We already seen what is outlier. When the data you are plotting in a graph deviated from all the data are at some point, but there are a few data points which are very much deviated from the actual data points. So such kind of observations are called outlier. So in statistics, we have a lot of outlier detection techniques. Next is Poisson distribution. We have seen whenever a distribution is linked with the time related factor, you try to apply Poisson distribution. It's a discrete probability distribution function. Okay, that expresses the probability of a given number of events occurring in a fixed time interval. So if certain event has happened. When you talk about probability, when you want to find out the probability which is linked with the time, then you apply Poisson's distribution. So what is the formula here? Lambda power x e power minus lambda by x factorial. P of x is given by this. The probability of an event happening is found out using this equation, lambda power x e power minus lambda by x factorial. Principal component analysis. So in dimensionality reduction technique, when you have multiple dimension data, you try to reduce that multiple dimension data into a lower dimension data, maybe from a 2D to 1D. How you reduce that? Making sure that the properties of those features are not lost. Maybe if you have F1, F2 as two features, you try to form a new feature F star, which is formed by combining these two features. But these values here in F star are formed by using this principal component analysis. So kind of clubbing or compressing these two features into single feature. The main important learning is that these features are not lost. Quantile. Okay, so a data point or a set of data points that divide the large data set into equal parts. So when you have a large of data set distributed, so quantile is something, a kind of a line which distributes the data. Random variable, you do lot of experiments. For each experiment, you get lot of outcomes, right? Always these outcomes are random. We do not know what could be the outcome. So there is a variable which holds the experiment outcome. Experiment gets one outcome, it is stored in a variable. First one time experiment is done, I get one outcome, it is stored in a variable. Second time same experiment is done, I get another outcome. So we get the outcome randomly. That's why it's called random variable. It means when you do an experiment n number of times repeatedly, you may get different outputs at different times. Since it is the output is random, where the variable where we are storing is also called as random variable. Root means square error. Same thing, only thing square root. For that mean square error, we are just finding out the difference. So these are all different versions of the same metric, like MAE, MSE, root mean square error. These are few metrics we use it in prediction models between to find out the difference between actual and the predicted values. Sampling. What is sampling? When you have a large data set, the process of selecting a small sample. Okay, the process of selecting a small sample from a large data point is called as sampling. And this particular the output of sampling technique is a sample. We get a sample. So randomly selecting few data points from a large data set. Singular value decomposition, SVD. We have seen this multiple times. Singular value decomposition. See, when you have a large matrix with you, doing operation on this large matrix is difficult. If I can partition this large matrix into three small matrices, where the product of these three matrices is again the original matrix. The product of these three small matrices is again the same original matrix. Since we cannot deal with large matrices, we try to decompose that particular matrix into different ways. So given a matrix A, you try to decompose that matrix into three different matrices, U, epsilon, and B transpose. Spearman rank correlation. So here also, when you want to correlate two variables, when you want to do correlation of two variables, two features also I can say in data set. No, we always have features F1, F2, so on, Fn. If you want to correlate between these two things, there are multiple formulas available to find out correlation. One among them is Spearman rank correlation. Its value can be between -1 to 1. So negatively correlated, positively correlated, 0 means no correlation. Standard deviation, the amount of dispersion in a data set. So how they are distributed, how the data is dispersed, or we will say that how they are spreaded to each other. T-test. So, you know, this we are seeing multiple times. In hypothesis testing technique, we have a test called T-test, which follows T distribution, that follows T distribution table, statistical table, So it is used to find out the significance, if is there any significance difference between two groups or between a population and a sample. Univariate analysis, analyzing the variation of a single variable. Multivariate also we have seen. Variance, or maybe it's repeated again, variance is repeated. Yeah. So XGBoost, there is no scope for this here, but still, since there is no function with X, we have included this XGBoost. So it's an open source library for gradient boosted decision trees. Okay, so it's one technique. XGBoost is one ensemble technique. I will just talk about this word, ensemble learning. You have a lot of algorithms for different tasks. For prediction, you have certain tasks. For classification, you have different tasks. When you are doing classification, if you are using under classification, in classification, you have many algorithms, A1, A2, A3, A4, for example. So you can use this, or this, or this. But what if we combine all these four to do the classification? Such kind of models are called ensemble models. Ensemble models. Combining multiple models together is called ensemble model. So in that, one such technique is XGBoost. So gradient boosted decision trees. It is used in gradient boosted decision trees. Z score. So X, Y, Z, right? Z means, we know, to understand the difference between Z test and Z score. Whatever the value we find out, no, Z calculated, that is your Z score. So these are few terms and terminologies which are linked with mathematics, A to Z terminology, and they are widely used in machine learning and data science. So most of these definitions, maybe these are few, only a few from what we see in machine learning and data science, but there are a lot of such terms and terminology used in data science and machine learning.